This lesson is on negative exponents and reciprocals. If you see an example below that is similar to the current question you're working on, you can download my app referenced in the video caption and use it to quickly navigate to the below example within the lesson. Negative exponents are the same as the reciprocal of a number. So what do I mean by that? What is the reciprocal of 5? 1 over 5. What is the reciprocal of x? 1 over x. What is 5 to the negative 1 equivalent to? 1 over 5. What is x to the negative 1 equivalent to? 1 over x. So you can see the reciprocal is just 1 divided by the original number, and basically in our negative exponent cases, you replace the negative part of the exponent with 1 divided by, and then rewrite what you had in terms of your base number and your exponent on the bottom of the fraction. We'll look at some more complicated examples soon. So the general rule to switch between a power with a negative exponent and a reciprocal is x to the negative n equals 1 divided by x to the n, where x cannot equal 0. So, as you can see, our x to the n stayed now on the bottom of in the denominator, and then our negative was replaced by a 1 divided by, a 1 in the numerator and a fraction there. I typically don't like working with negative exponents in a question, so a first step I do with a question that has them is to convert them into the reciprocal form. So I like this form when I'm dealing with these kind of negative exponents, and that will enable you to do canceling and use other exponent laws to simplify. So let's kind of try to put this into more basic English, more basic rule in everyday language. If you see a negative reciprocal, to rewrite it using the rule above, simply say 1 over. Literally just say 1 over to yourself, and you can write then 1 over, so 1 divided by, and rewrite the base number and exponent number without the negative sign in the denominator of the fraction you just created. So the base number in this case here is the x, the exponent is n, so we rewrite those two in the denominator, so we don't actually get rid of anything here except the negative with the 1 divided by. So when you see negative exponent, think to yourself 1 over. Oh, that's easy, that's just reciprocal, I'm going to do 1 over now. The 1 over part replaces the negative sign in the exponent. So let's look at some examples. Example 1, evaluate 2 to the negative 3. So the answer is 1 over, and then 2 to the 3, so 1 divided by, and then you keep what you had before as the base and the exponent, 2/3 on the bottom, and of course you'll want to simplify the bottom here to an 8. So your final answer is 1 divided by 8. Example 2, evaluate 2/3 to the negative 3. So again, you see that negative exponent, write 1 divided by, and then copy everything else you had before into the denominator, 2/3 to the 3. 2/3 to the 3 here. Again, that negative exponent was replaced with 1 divided by, 1 over. And the bottom here we can simplify a bit. So just pay attention to where my cursor is. We have 1 over still, and then you apply this cubed to everything on the inside here. We'll look more specifically at that exponent law in a later lesson. But so you have 2 to the 3 is 2 times 2 times 2 is 8. And 3 to the 3 is 3 times 3 is 9 times 3 is 27 on the bottom here. And then I believe you should know this already, but if you don't or you forgot about it, a little recap. When you have something dividing by a fraction, you can simplify this quite easily by saying to yourself, okay, 1 divided by this fraction is the same as 1, the top, multiplied by the reciprocal of the denominator there. So 1 times 27 divided by 8. All you do is flip that and multiply it, and then you simplify 1 over 8 over 27 to just 27 over 8. So make sure you remember how to simplify a fraction in the denominator of a bigger fraction. You just multiply the numerator by the reciprocal of the denominator there. Example 3. Evaluate negative 1/3 to the negative 2. So notice here I put a negative sign in line with the fraction in the original question. That's one way of writing a negative fraction. That negative could also be written right below the denominator, or as I chose to rewrite it here before the numerator. Typically, I like to just put it before the numerator. Any of them are okay to deal with. They're perfectly fine to use them in each of these forms. But when you're now dealing with later on, when we apply the square to the numbers on the inside, you don't want that negative necessarily just in the middle here. I find it easier to just deal with it being attached to one of the numbers. And it doesn't matter which one, but common practice for me anyway is applying it just to the numerator. So if you see it there in the question, just put it in front of the numerator and continue on like you normally would. So that's what I did here. And then I applied the law here. So that negative exponent in front of the 2, I said 1 over, and then I rewrote negative 1/3 squared in the denominator here. And then, as I mentioned, we'll apply that squared to the negative 1 on the top and the 3 on the bottom. When we do that, we are having negative 1 times negative 1 on the numerator of this fraction down here, which will just be a positive 1. And then 3 squared is just 9, of course. And then we'll use that same rule where we're dividing by a fraction. That's the same thing as multiplying by the reciprocal of that fraction. So multiplying by 9 over 1 instead. And so that more complicated looking original question there, all that just simplified to a positive 9. Example 4. Evaluate 0.91 to the negative 3 to the 100th place. Since there is a decimal in this question, just try to use your calculator first. So plug in 0.91 to the, and then you want to make sure, well, typically, and it's always good practice, to put brackets around your exponent. So 0.91 to the bracket, negative 3, end bracket. Note how I put negative 3 in brackets, how I just mentioned, and it is best to get in the habit of putting the exponent and even the base if you want it in brackets on your calculator. So I repeated that a couple times there, but it is important to emphasize that. So please don't forget to do that. The answer here is 1.33. Example 5. Evaluate 4 to the negative 3 halves without a calculator. So we have 4 to the negative 3 halves. Let's use our law now with negative exponents. So you see that negative sign, say to yourself 1 over, write 1 over, and then rewrite 4 to the 3 halves in the denominator. So again, you basically rewrite everything here except without the negative exponent. That's the whole purpose of doing this, getting rid of the negative exponent, even though it looks maybe more complicated, but this is nicer to deal with. I find it is anyway. So we have a base number with an exponent, fractional exponent here in the denominator. We want to do this without a calculator, so let's remember how to change this into radical form. Our 2 goes into the index, but since it's a 2, it's just the square root, and we don't have to write the 2 there. And our 3, I'm going to keep it on the outside of the entire radical instead of directly connected to the 4, because I see square root of 4 is just going to be a 2. So let's simplify that square root 4 to a 2 there, and then 2 cubed is just 8. Example 6. Evaluate 27 over 8 to the negative 2/3 without a calculator. So as you can tell, our examples have gotten a bit more complicated, and this is the final example for this lesson. So we have 27 over 8 to the negative 2/3. Let's use our law. So first, let's just deal with that negative. We don't like negative exponents. Let's get rid of that. We write 1 divided by, and then rewrite everything else in the denominator here. And now I've applied the, again, you apply this exponent to everything on the inside, but using the multiplication rule with radicals, I'm just going to choose to apply the 3 to be the index on the top and bottom, and then I'm going to keep the squared on the outside. And the reason for that is I know the cube root of 27 is just a 3, the cube root of 8 is just a 2, and now I will apply the square to the 3 and the 2, and we'll get, just looking here first, 3 squared is 9, 2 squared is 4, and then 1 divided by 9 over 4 is the same as 1 multiplied by the reciprocal of that denominator. So 1 times 4 divided by 9. And that just equals 4 divided by 9. So we started out with something relatively complicated and ended up with something much less complicated. And that's the end of this lesson.